Hello, everyone. My name is George Cruz. I worked on this project with HaoDinhMai and Anna Hernandez. So the purpose of our project, we decided to make an Arduino version of Red Light, Green Light, inspired from the Netflix series Squid Game. So instead of being the player trying to reach the finish line without getting caught and dying, um, you'll be the player that will be the game host and will try to catch and kill as many people as possible before the game ends. The project is used with a variety of components such as the Arduino 1, 3, um, R3, breadboards, resistors, push buttons, LCD display, LED, RGB, wiring, and a piezo. So our focus in this project is to understand assembly algorithms by demonstrating and building an Arduino project, sharing the fundamental rules of red light, green light, with Arduino hardware and code. So the game host is the player who each time successfully kills a player from crossing the line, like before they do that. So I will be demonstrating that part and then showing the code as well. So before I start, the code does come from part of the library that we use from Liquid Crystal. And then this is the rest of our code, which I'll show in a bit. So the way that the game works is that as I start the simulation, it'll say welcome players. And then we added music onto the piezo, which is the thing right here that will allow the Arduino to play music. So this is music from the Cantina band from Star Wars. And as you can see, so right now the player is trying to cross the green line here. Consider the green line. So then it's 0. So then as I use the push button to catch the player, so that's 1 already. And then there's another player. So there's like not, as you see one of these stick figures come by, doesn't mean that's just one. There's like multiple passing by. You could catch as many as you want. Like for example, right here, I caught 4 and then I'm catching more and it adds on. And if you notice right here that after like 2 times that I didn't catch someone, it starts the game over and I have a clean count or clean score. So as you can see, also the lights too, the LED lights, RGB. Every time someone crosses, it's red. Every time I catch someone, it's green. See, turns green. And then sometimes I don't catch someone, then it turns red. So that's basically how this game works. Okay, so for the code part that I did was I did the code for the LED lights. So as you can see on the green LED, this on digital right just means that it is when it's on, and then the red light is low, meaning that the red light is off. And then the reverse would be that when it's high, when the red light is high, then it's on, and then the green light is low, meaning off. And then I use the switch case statement, case 0, meaning that the red LED is on, and then red LED, and then you break the case. And then case number 2, case number 1 would be that if the green LED light is on, then it breaks. And then either if the red LED or the green LED is not on, then it'll just stop the game, which it shouldn't happen, but mostly it'll happen when like, there's like 2 red LED lights on, then it's when it'll like restart the game, but it shouldn't stop the game. So yeah, this shouldn't stop. And then also for that, obviously you need to initialize those variables. So the initial variables are used from the library that's included. So right here, initialize red light 9. So it go on digital pin 9. And then for the green light, it would be on pin 10. And so yeah, that's how you initialize those lights. And then as well as going to void setup, to set that up, you go to pin mode, add the red light and then green light, which configures the red light as an output. So this is what sets the pin to give the output. And yeah, that's what I did for part of the code.
So the library we used in our code is called the Crystal Liquid Library. This library was used to connect the LCD display to the Arduino. As you can see, the library specifies how the pins should be connected. And originally, when you first connect the LCD, I believe it gives you a sample code of Hello World, and you'll be able to see it on the screen display so you know it's working. So in our code, the library is initialized with the numbers of the interface pins, which are all in this row of Arduino. So the characters you saw appear on the screen were created using this code. So if you look at the screen, you will notice there are many squares, and inside are 8 rows of smaller squares. I'll show you a glimpse just for reference. So back to the code, all of these rows represent the 8 rows of smaller squares, and the one represents the squares that are filled in. So in that way, the characters can be customized. In the void setup, both of the characters are declared as byte 1 and byte 0 using the commands LCD create char. Then the LCD is initialized with 16 columns and 2 rows. Then following, there is a command interrupt, which is triggered every time the button is pressed and is linked to the button method. Here. Which has an if statement that if the button is not pushed, then the level is equal to 0, else the level equals 1, and the button is connected to pin 6, as you can see right here. Then going back up, the variable I is initialized to 15 in our void loop to be used in our while loop. Inside of the while loop, the screen is cleared and all the custom characters are printed on the screen by calling their methods, as you can see right here. In their methods, they are all pretty much the same. The cursor is set to a specific location, and then the command for them to print. Only the top one is the cursor is set to go along with the level, which allows the character to move down from row 1 to row 2. Then back to the while loop. There are 2 if statements, which determine if the game stops or continues. So while the level is 1, the game should continue as the line stops. stop game is skipped, and then after that we print the custom character man, which is the one that is running on the screen as it moves with I, as the LCD cursor at the top is set to column I, row 2. Then after that, the cursor is set to column 10, row 1, which is where the printed score starts, and then the code is delayed. I is decreased and the score is increased if the level is not 0. Then finally, we have our stop game method, which I mentioned earlier in the void loop. And this method basically clears the screen, then sets the cursor to the top left corner to print the phrase, and then it's set again to print the score. The code is then delayed by 300 milliseconds or 0.3 seconds, I believe, enough for the player to see their final score. And then the level is made equal to 1 and the score equal to 0 and I equal to 15. And the code is once again delayed before letting the user play again by returning back to the function from which the stop game method was called, which is up here. So we faced many problems while writing our code. Originally, I wanted to have a keypad with the movements up, down, right, and left, but there wasn't really enough time to implement it, so I reduced it down to one button. A problem one of my peers faced while coding was trying to get the speaker to work with the game, because at one point the speaker would interrupt the game, but they were able to incorporate it well. Another problem one of my peers faced was making the light match up with the game and button, as at first it was just continuously blinking, but they were able to do so successfully. And I believe it's an important part, as that's the title of the game. Overall, the game is playable and has room for more features to be added.
Hello everybody, my name is Hao, and for my part in this project, I wanted to enhance the quality and the experience of the player, so I wanted to do something different. I got this off of GitHub, however, it's pretty much integrating a song into a piezo, and what a piezo speaker does is pretty much, there's a metal component within the speaker that converts voltage and energy into sound frequency. You do this by declaring all the notes. The piezo will recognize the note. Then you enter the make of the song, so you pretty much write the song with the notes in there, and then you adjust the frequency and the duration of each note by using a mathematical function, and pretty much this would play once the welcome screen goes on the LCD, which I wrote also. It is LCD clear, so you clear the screen and then you print welcome player. It will be delayed for 2 seconds, and after that it will clear. Furthermore, I also added a tweet to the piezo, so every single time the player crosses the line, the buzzer will emit a sound frequency of 800 Hz delayed for 1 second, but every single time the player is caught, if the stimulation is caught by the player, then the sound frequency would emit a 450 Hz delay for 1 second. So if I were to start the stimulation, we'll welcome player screen, and then the music goes on. And then you hear that. Almost so close. There you go, you would hear the 450 Hz right there.